Hello everyone, this is Chinnaiah Kalpana here. In this video, we're going to see a problem from partial differential equations. So let's get going. Problem: form partial differential equation from z equal to e power ax plus by into f of ax minus by by eliminating the arbitrary function f. So we are given a relation z equal to e power ax plus by into f of ax minus by, and we are asked to form a partial differential equation by eliminating this f. So let's see. Given z equal to e power ax plus by into f of ax minus by, right? Consider as equation number 1. Now let's partially differentiate it with respect to x. Partially differentiating one with respect to x. Just apply dou by dou x on both sides of the equation. Now, here we are given e power ax plus by into f of ax minus by, right? Now we are differentiating it with respect to x. Since we are partially differentiating with respect to x, so we'll treat y as constant. Now this gives us dou z by dou x equal to, here you are having u into v form, uv, right? So we are going to apply uv whole prime formula, that is u dash v plus v dash u, right? Consider e power ax plus by as u and f of ax minus by as v. Then we will get partial derivative of e power ax plus by into f of ax minus by plus partial derivative of f of ax minus by into e power ax plus by, right? Fine. We know that partial derivative is e power ax into a, right? So here in the place of ax plus by we have this, just we can write like this, okay? Much easier, right? Partial derivative of e power ax is e power ax into dou by dou x of ax, that is inner derivative. So here also we are going to apply the same formula. Instead of ax we have ax plus by, let it be, that's not a problem. And also we know that dou z by dou x can be replaced by the notation p. So we'll replace it by p, we'll get p equal to partial derivative of e power ax plus by with respect to x is e power ax plus by into inner derivative dou by dou x of ax plus by, right? Into f of ax minus by plus partial derivative of f of ax minus by is f dash of ax minus by into inner derivative dou by dou x of ax minus by into this e power ax plus by, right? This gives us p equal to e power ax plus by into partial derivative of, here we are partially differentiating with respect to x, so we'll treat y as constant, okay? Here a is constant, right? We'll write a into partial derivative of x with respect to x is 1 plus by is constant, right? By, partial derivative of by with respect to x is 0 into f of ax minus by plus f dash of ax minus by into partial derivative of x with respect to x is 1, or partial derivative of ax with respect to x is a simply, minus partial derivative of by with respect to x is 0 into e power ax plus by. This gives us p equal to a into 1 a into e power ax plus by is a into e power ax plus by into f of ax minus by plus a into 1 a minus 0 is a into e power ax plus by is a e power ax plus by into f dash of ax minus by. Okay, you can consider it as equation number 2, or we'll just bring this term to LHS and this becomes p minus a into e power ax plus by into f of ax minus by equal to a e power ax plus by into f dash of ax minus by. Consider as equation number 2. See, if you notice, you have z equal to e power ax plus by into f of ax minus by, right? So we can replace this term, e power ax plus by into f of ax minus by this z. Okay, we'll do that in the last, in the coming steps. Okay, while finding PDF, we'll just replace it by z, not now. You can also replace it by z now itself, but it's always good to replace it later. Okay, now let's partially differentiate 1 with respect to y. But now let's partially differentiate 1 with respect to y. Partially differentiating 1 with respect to y. Just apply dou by dou y on both sides of 1. We'll get dou by dou y of z equal to dou by dou y of e power ax plus by into f of ax minus by. Since we are partially differentiating with respect to y, so we'll treat x as constant, and this gives us dou z by dou y equal to, here we have u into v form, right? Here we need to find derivative of uv. So we are going to apply this formula again. We'll get dou by dou y of u into v plus dou by dou y of v into u. Okay, so here we are having partial derivative of e power ax plus by. We know that derivative of e power ax with respect to y will be e power ax plus by into inner derivative, that is, right, easy, and you get e power ax plus by into derivative with respect to x is 0 plus b into, here we are part derivative, finding derivative of this function with respect to y. So derivative of y with respect to y is 1. So I'll get b into e power ax plus by. Right. For now, let's find here. And also we know that dou z by dou y can be replaced by the notation q. So we'll just replace it by q. We'll get q equal to partial derivative of e power ax plus by with respect to y is e power ax plus by into inner derivative into f of ax minus by plus partial derivative of f of ax minus by with respect to y is f dash of ax minus by into inner derivative dou by dou y of ax minus by into e power ax plus by, right? This gives us q equal to e power ax plus by into partial derivative of ax with respect to y is 0 plus constant b into partial derivative of y with respect to y is 1 into f of ax minus by plus f dash of ax minus by into partial derivative of ax with respect to y is 0 minus b into partial derivative of y with respect to y is 1 into e power ax plus by. Right. This gives us q equal to b into 1 b into e power ax plus by is b e power ax plus by into f of ax minus by, right, plus b into 1 b, 0 minus b is minus b into e power ax plus by is minus b e power ax plus by Minus into plus gives minus b e power ax plus by into this f dash of ax minus by, right? Now let's bring this term to LHS. You'll get q minus b into e power ax plus by into f of ax minus by equal to minus b e power ax plus by into f dash of ax minus by, right? Consider as equation number 3. Okay, we got equation number 3, which is q minus b into e power ax plus by into f of ax minus by equal to minus b e power ax plus by into f dash of ax minus by. Consider as equation number 3. Now observe 2 and 3. By observing 2 and 3, we can say that we can eliminate f dash using 2 by 3, and later we can just replace e power ax plus by into f of ax minus by using this z by 1. Okay, let's see. Now using 2 by 3, okay, gives us p minus a into e power ax plus by into f of ax minus by LHS of 2 by LHS of 3 equal to RHS of 2 by RHS of 3. Okay, f of ax minus by equal to RHS of 2, a into e power ax plus by into f dash of ax minus by b into e power ax plus by into f dash of ax minus by. Right now you can cancel f dash and e power ax plus by, right? Fine. And also since e power ax plus by into f of ax minus by equal to z by 1, let's replace this and this by z. This gives us p equal to, it's p minus az by q minus bz equal to, here you'll get minus, right? You have minus, so a by minus b. Now make a cross multiplication and simplify it. This gives us minus b into, or you can just take this minus here. Better you can write one more step. P minus az by q minus bz equal to minus a by b. Now make a cross multiplication. You'll get b times p minus az equal to minus a times q minus bz, right? This gives us bp minus abz equal to minus aq plus abz, minus into minus plus, so you'll get minus abz, right? Now what we'll do is we'll just write the terms involving p and q in LHS part and the terms that does not involve p and q in the RHS part. Okay, so what we'll do, we'll just take this term to LHS and we'll just you just need to bring this term to LHS because it involves q, and take this term to RHS, it does not involve p or q. Fine. And I forgot to notice here you're having minus, it's minus bz. If it is plus abz, then you can cancel abz and abz, right? Since you are having minus, so you have to take this to RHS. Fine. Now we'll get bp plus aq equal to abz minus abz becomes plus abz, right? This gives us bp plus aq equal to abz plus abz gives 2abz, which is the required partial differential equation. Well, we have seen a partial differential equation problem in this video. I hope you'll understand. We'll see you in the next video. Until then, bye bye.